So now what we want to look at is this question. Is the function fx x squared, so the function that you have will be x squared if your values of x are less than 3, and the function will be 2x plus 3 if the values of x are greater than 3. So is this function differentiable at all points? So what we need to look at here is, firstly, we know that if I'm looking at each of these functions separately, so if I had two different functions, fx is equal to x squared, and the other one fx is equal to 2x plus 3, I know that both of these functions are basically both continuous and smooth. So on their own, they're actually going to be differentiable. But now they're getting combined. So one of the first things that you can do is to find out if it's actually continuous. So the point where these two functions are going to get merged at is actually x is equal to 3. This is where this function basically ends and the other function starts. So one thing you can do is have a look at what the value of 3 gives you at each of, so at x is equal to 3, what's the value of each of these functions? If they're different, then you instantly know that it's not going to be a continuous function. So for example, if I had a function that looked like this, and let's say that's at x is equal to 3, then I know instantly, well, that's a very weird 3, but that's a 3. Okay, so I then instantly know that this is actually going to be a problem because these two functions don't start from the same position and therefore it's discontinuous, okay, and it wouldn't be differentiable. So the first thing I need to know is if these two functions, x squared and 2x plus 3, are actually going to start from the same point. So to do that, I say, okay, what's my f of 3? If I look at x squared, so if I'm just looking at my x squared, if I put f of 3 in there, so instead of x, I put in 3, what am I going to get? And that's going to be 9. And what is my value going to be if I'm looking at fx is equal to 2x plus 3? If I'm looking at this function, what is the value of the function going to be, or the y value of the function going to be if the value of x is 3? So again, you can see that that is going to be 9. So that's good news, kind of. That basically tells you that your function is continuous at least. Now what you need to know is whether it's smooth. One thing you can do is to sketch this graph. So to sketch this graph, we just say, fine. This is a graph of x squared, okay? So this is just a normal graph of an x squared function. This is supposed to be touching at x is equal to 0. And now what we say is this graph of x squared is actually going to only come into play when the values of x are less than or equal to 3. So if we take this as the point x is equal to 3, what that function is telling us is any point below this x, that function is going to take place. So if I at these points, you're going to have this function. Okay, so draw it again. So we have 3 here, and then your graph starts from there. Okay. So anything beyond that, you can't have your x squared graph, obviously. Then you want to look at 2x plus 3. It says 2x plus 3 is going to only come into play after x greater than 3. Okay, so we draw our 2x plus 3 graph. So if you remember, you just need to know what your values of x and y are. So this is my fx is equal to 2x plus 3. You choose any random values of x that you want. I say 0. And then you substitute that into here and find out what value of y that gives you. So if I put in f of 0, that's equal to 2 times 0 plus 3. So that actually is 3. So the y value corresponding to this value of x is going to be 3. And then you put in any other value. So for now, I put in 3 because that's just going to make my life easier. So if you put in x of 3, again, you do the same thing. So that's 2 times 3 plus 3, and that's a 9. Okay, so that means that the value of y corresponding to this value of x for this function is going to be 9. So now you have two ordered pairs. So you have 0, 3, and you have 3 and 9. And using these two values, you can now draw your line. So you go here, I'm at 0, 3, so that's 1 point, and the other point is 3 and 9. That's supposed to be 9. Okay, so that's 3, 9, and that's 0, 3. So this basically would correspond to 9. Okay, and now we just join the 2 points. Okay, and this line is actually going to only come into play after x is equal to 3. So this is the only thing that you're going to see. So if I draw it here, it's going to look like that. Okay, that's a filled out line because your value of f of 3 is equal to 9. So at x is equal to 3, your y value is 9, and the value of 9 has already been accounted for because this function includes x is equal to 3. Okay, so this is a continuous function, but unfortunately it's not smooth. So that means that this whole function, this function here, is not actually differentiable.